Good morning, everyone. Welcome back to another exciting day in mathematics. How's everybody doing? Good? How was home play last night? Good? All right, good. All right, so warm-up 77 is on the screen. Shouldn't take you more than 5 minutes. Let's get started, please. Copy and go. All right, once again, it shows they put the spinner at the top, the coin on the side, combine all of them, there should be 8 total outcomes, and it's a classical. That is correct. All right, copy the agenda, please. Warm up 77. We're still in the introductory part of probability, and tonight's home play, you're going to the end of 4-1 to the section titled Applying Concepts. You're going to do numbers 1 through 7, 1 through 7 only. I am going to include the slide in this presentation, so here's the code. Once you finish copying the agenda. Code SJ5TP, SJ5TP. SJ5TP. All right. Last night's home play looks like this. It was numbers 15 through 18 only. So go to Canvas, turn that in. And how about I count that as a pop part today? Let's go. Ooh, thank you, Mr. Q. You're welcome. I got you. Turn that in. And this is tonight's home play. All right, then get a Cornell note ready. I'll give you some time. Copy and go. All right, here we go. I can identify and compute the basic probability. I can identify and compute basic probability. I can identify and compute basic probability. So as we have been traversing this new section, starting last week with probability and this week, we've covered the definition, and we said we were going to be in classical, empirical, and subjective probability. We started last week with classical, we went into empirical, and today we're actually going to wrap up subjective, by the way. All right? So, from there we started with classical. We got a formula for classical, is that correct? Yes. From there we went to empirical. We got a formula for empirical. By now you should know that one already. From there, we did an exercise yesterday to compare classical versus empirical. We had formulas for each. Is that correct? Yes, Mr. Q. And we said that both of them should be equal to 1. Well, actually, the empirical was very close. Remember that? 0.997, 0.996, 0.999. Some of you actually got 1, but classical is exactly 1. 1/6 plus 1/6 plus 1/6. Plus 1/6 plus 1/6 plus 1/6 should equal to 1, whereas empirical was approximating 1. All right, so today we're going to make sure we wrap this up. So on your paper, write classical. Next to that, write empirical. And next to that, write subjective. All right. So, since you guys are really focused, and by now you should know what each component is, turn to your neighbor, let them know what classical is versus empirical. Then Aaron's going to get us started. All right. What is classical versus empirical? Oh, it looks like Alexa's got this as well. Very good. All right, Aaron. Classical is set. Empirical is chance. Okay. And in other words, look up for classical, which is already set. I'm going to write it's basically theory. Theory. What does that mean, Mr. Q? That if I gave you the task like I did on the warm-up to come up with a table using a spinner and a coin, even though you did not have them in front of you, you were actually, in theory, were able to create a table from it. Is that correct? Whereas empirical is by chance. However, in order to find that chance, what did we do? We had to do what? Experience. We have to go through it. Experience, you collect the data collection, and that's how we determine the chance or the probability of each of the outcomes. So that's through experience. All right? All right. So today we're going to do the intro and hopefully done with subjective. So for this one, you can close your Chromebooks really quick. And I'm going to show you a video, and I need you to stay focused on the video. And let me set this up. Give me a second. All right, this video that I'm about to show you, it takes us back 13 years ago. 13 years ago, there was a phenomenon in the NBA that they labeled Linsanity. There was this player, the first American-born of Chinese descent player that made it to the NBA, and then he started doing really, really well. He had a streak of averaging at least 25 points per game. And in this game, he's playing against one team that they were kind of like talking a little smack about him. And this was the game that he was going to come in and you know, do some damage there. So what I'm going to do, I'm going to play this, and I need you to stay focused to the screen. All right, focus please. So after watching that Jeremy Lin video of his highlights against the Lakers, I want you to write on your screen probabilities for Jeremy Lin in that game shooting the ball and passing the ball. So write some numbers on your screen, please. Go. Here go some numbers from your colleagues. Look up to the screen. 12 out of 20 for shooting, 16 out of 20 for passing. Okay. 11 shooting, 1 passing. 12 out of 20 shooting, 10 passing. Shooting and passing. Wow. 65% shooting, 35% passing. 3 out of 5 shooting, 1 out of 6 passing. 12 out of 20 shooting, 8 out of 20 passing. 3 out of 5 shooting, 1 out of 5 passing. So what happened to the other one? Oh, okay. Be nice. 60% shooting, 40% passing. 12 shooting. Wow. 4 out of 5 shooting, 2 out of 5 passing. What? That's 6. Anyways. 12 shooting, 2 passing. 15. Okay. 8 out of 10 shooting, 4 out of 10 passing. 70% shooting, 30% passing. 6 out of 10, 4 out of 10. Wow. Wow. 46, 60, 40, and so on and so forth. So, what you guys just experienced, guys, is what we call subjective probability. Subjective probability. We already know what classical probability is, what empirical probability is, and after watching a video, I asked you for data and you gave me subjective probability. Tell your neighbor what subjective probability is in your own words. Talk about your neighbor. What do you think subjective probability is? After you saw all those numbers that I was reading. All right, looks like Cole's got it. Very good, Cole. Well, let's go with Brandon Doherty. Random data. Okay, write that in. Random data. In parentheses. What does that mean, guys? Random data. Okay, so a guess, but specifically each point of view. Like some of you weren't watching the video and you just wrote whatever. Some of you were paying attention and you actually got a lot of detail. And some of you were just like enjoying the show, and at the end when I asked you for data, you just went by what you remembered. Therefore, this kind of probability is let me write it like so, the least accurate. Do you agree with that? The least accurate? Yeah, did you guys see all the different numbers that we got? Some of you 60-40, some of you 75-25. Some of you gave me like 10 shooting, 1 passing, so that's like a lot difference. So it depends on the point of view. All right. So there you have it. These are the 3 different probabilities that we're going to be looking at. However, which is the one that we're going to use the least, guys? What do you guys think? Subjective, because that only depends on the point of view. So let me send you a slide. You can send me your notes for this. Give me a second. For classical, we need a table really quick. By now, you should know how to build a table for one die in classical. Pretty much what we did the other day, but also by now it's O for outcome, P for probability. So, should be almost done building this table. Kieran, what do I write here? The number 1, 2, 3, 4, 5, and 6. And what is the probability for each? 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. And of course, our formula for that is P of E equals N of E over N of S. All right, over here, table. Our formula, P of E equals frequency over the total number of frequencies. All right. So today I want us to do another activity very similar to what we started yesterday. And the only thing is that now I'm going to give you the set amount of n for this one. So for this first one, I want n of 12. Tell your neighbor what that means. What does n of 12 mean? All right. What does N12 mean, Mel? Yeah, the total number of rows. Total number of rows. Only 12. So, with that said, you're going to need one die each person. So come get a die from the back. And I'll give you guys some time to record your data here, your tallies for only 12 rows. Go. All right. So you should be done with your 12 rows, yes? All right. I'm going to have, go with Dayeli. Give us your numbers. How many frequency for 1? 3. Hold on. For 2? For 3? For 4? For 5? And for 6? Okay. Not bad, not bad. And you guys already wrote your numbers here as to what you got, yes? So that was good at n equals 12. Okay. So, underneath that one, let's do another table. And you create some space over here. O for outcome, F for frequency. 1, 2, 3, 4, 5, 6. All right, but now we want a big number of n. Dale, we pass someone. Okay, I'll pass it to Vianney. Give us a big number for rows. How many rows? 37. Okay. So, 37 rows. I'm going to give you guys some time on this new table. You have your die. Start tallying your results until you add up the entire set up to 37. Ready, go. Those of you that are following on YouTube, make sure you do this exercise. Go. All right. So, add them up for each outcome. How many tallies for each? Now that you rolled 37 times. All right. Bless you. Let's see. I'm going to use Lulu's numbers. Lulu, give me your numbers. 9, 6, 7, 5, 6, and 4. All right. So, let me do an observation really quick. Look up to the screen. When we started, we only did 12 frequencies, total of 12. And look at the numbers. We see 2 numbers with far more frequencies than 2, and the other 2 are pretty close. But other than that, it looks like 2 of the numbers are staying behind, like far behind. Do you guys notice that? Yes? Now look at after 37 rows, look at the numbers now. Look up. What do you guys notice? Do you guys notice anything? They're getting closer, is that correct? So now check this out. This is, Lulu's numbers are 37. So if I was to add 5 more different datas from 4 different people, because I already have Lulu's and I asked for 4 people their numbers, that's going to give us 185 rows. So this is what I want you to do. I want you to go get the numbers of 4 more people around you. Write them next to yours, because we're going to add them up and see what happens. Get up, do that right now. All right, once you have all your numbers, add them all across, all the frequencies for 1, the frequencies for 2, the frequencies for 3, all the way across. So, let me when I call your name, give me your numbers, please. Max, numbers. Yeah. 9. All right. Z, give me your numbers. Huh? Yes. 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 What is it? 7. All right, Vanya, give me yours. All right. Aleshka, give me yours. All right, so now that I have all those numbers, I'm going to add them going that way, and now my N, since I have 5 different people, that's 185 rows. So that's, let's see, 6 and 6, that's 12, plus 3 is 15, 29. This one is 8 times 3, 24, plus 6, that's 35. 99 is 18, plus 4, that's 22, plus 12, that's 34. 5, 5, 5, 5, that's 24. This is 15, 21, 29. 7, 7, 7, 21, 34. Okay. That's decent. All right. Are we there so far? Once again, look up. We started off with only 12 rows over here. And what did we say happened to our data? Here, 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 and here. That what? That they were a little bit further apart, certain numbers. Is that correct? After 37 rows, which is just this one, we started seeing that it was evening out. And now look at after 185 rows. Look at your numbers, look at my numbers. What do you guys notice? So now that you have your numbers, I want you to think about this. Look up. What if I asked you to do this? Talk it over to your neighbor. Let them know what do you think is going to happen to these numbers if I ask you to do that. Talk it over to your neighbor. What do you think is going to happen? Talk it over to your neighbor. It looks like Max has got it. Very good, Max. All right. Brandon, Darty, pass someone. Logan, what do you think is going to happen if we continue to 1,000 rolls? They're going to be equal. So Logan's predicting that these, for each of these outcomes, the frequencies are going to be equal. Hands if you agree with that. That is correct. And by the way, on your paper, I want you to write this. Law of large numbers. Colon. Law of large numbers. So basically what we just experienced right now with empirical probability is the law of large numbers, which says the law of large numbers is when turn to your neighbor and fill in the blank. Law of large numbers is when what? We just experienced it right now. Is when what? Is when what? Logan, pass him one. Who? Amelia. Large numbers is when when the more frequency we have, the outcomes become equal to each other. Hands agree, if you agree with that? Yeah, because they're starting to balance out on all of these. Now check this out. If they all balance out, look where we're headed to. Look up, look up. You're going to be like, what? Look. Aren't these all equal? Oh, snap. That's what I'm talking about. All right, we'll stop right there, please. Law of large numbers. Make sure you keep that in mind. That's going to be also part of your home play. Make sure you do your practice today. And those of you following on YouTube, you have the code to log in and get that practice in. See you guys next time. Peace.